So why we are doing compression? Why would compression is doing when we are sending the data on the network? So it's just to save our network bandwidth, network usage. We are doing compression. So GoldenGate provides an optional data compression when sending over TCP/IP. Automatic decompression happens. So you have to just compress it. You need not to do decompress of your data because automatically your data would decompress when reached on the target. Okay, just for the network save and not much configuration required over here. Okay. Compression threshold allows user to set a minimum block size for which to compress. So it is the minimum block size for which to compress. The compression threshold rate requires. Okay, GoldenGate uses zlib compression technique to compress the data. Okay, so this is your syntax. You can see in the last line. This is the syntax, and this would be put in the pump parameter file. Okay, when you're sending, because pump used to send the data, so in the pump parameter file, you have to send it. You have to specify it: RMT host, manager port, compress threshold. So it says to compress. So it is something like it will compress the data. Threshold will set the size of the blocks. Okay, the minimum byte size for each compression will occur is 750. So if you don't specify, it becomes 7. So you just need to add a line compress over here. It will be compressed. Okay, so just make sure your pump processing would be more. Okay, pump need to compress the data before sending it, but automatic decompression happening in the target. So no changes on the target side, because compression is only done with only one algorithm, zlib, and there is, you need not to specify any kind of algorithm, any configuration, because once target will receive the data and find it is compressed, it will decompress and write to the trail files. Okay, so not at all any configuration required, just add a keyword of compress over here. Now comes the important topic, that is encryption. So there are three kinds of encryption that we can enable in the database in the GoldenGate. One is the database password encryption. That is very important. We have to anyways do it. Okay, so you can just see in the parameter file, we are exposing the password like anything. We are putting the username and password, right? But definitely that is not suggested, because it is a kind of a DBA privileges user, right? It's a DBA user, and anybody can log in, and once anybody who is a GoldenGate privileges can log in and can on the database, right? So this is quite critical. So we have, first is that you have to encrypt the database password. Okay, you have to encrypt the database password. Second thing is message encryption. So messages, the data which is sent from source to target are known as messages. Okay, are known as messages. Whatever is written in the trail file and sent to the target are data known as messages. They're actually data. All your changes are made to the database, but these are known as messages in GoldenGate. So second is the messages encryption. You have to encrypt the messages which are being sent to the target. Right, so that second is the messages encryption. Now third one is the trail file encryption. So trail file is which you have kept over here. Anybody who is a GoldenGate admin can go ahead and read the trail file with the help of log dump. Right, so with the help of log dump you can read the trail file, but that is also risky, because you get to know what all changes happen to your database. So you can encrypt the trail file as well. Okay, clear? So now how to do it? Okay, how to do it? By default, it use this blowfish algorithm to encrypt your data. Okay, and so blowfish algorithm is used. So let us start it. How to do it? Go to your machine. Okay, so I use this. There is utility known as keygen. Okay, utility used to known as the keygen. This is known as a key generation. I say 128. Oh, sorry. I think 128 4. So it does mean it will generate 4 keys of 128 bits. Okay, 128 bits of 4 keys. Right. So minimum bit length, one minimum length is 128 only. So you can maybe have 256. Anything above 128, maybe 130, 140. It's your wish. Okay. Then I make a file known as keygen. ENC keys. Let me copy this. Not edit params. Okay, this is UX. So ENC keys. Okay, so there are 4 keys we have copied over here. I say VI ENC keys. Now I have to name these keys. Maybe I can name it like K1, K2, or maybe anything. K1, K2, K3. So we have 4 keys as of now, 4 keys with the name of K1, K2, K3, K4. Okay, this ENC key should always be in the GoldenGate home directory to generate the encrypted data. Okay, to get the encrypted data, these keys should this file should always be in the GoldenGate home directory. Okay, so now how to proceed that? We go to the GoldenGate GGSCI mode. Now this same file should be in the target as well. Okay, what's a target home directory? Same file should be the target of target home directory is U02 GGT. So we'll copy these files. These files need to be copied because considering concerning when we are sending a message encryption, when we are doing message encryption. uh, Considering messages encryption, when you encrypt the messages, then something same encryption should be at the target as well to decrypt your passwords for sourcing. Something should be at the target as well, right? So the target should also have the same keys. Okay, so we would be using these keys. So just understand the steps. We have to generate the key, 4 keys or 3 keys, 2 keys, 1 keys. It's your wish. Okay, give the key name to it, maybe SK1, SK2, or maybe Ravi1, Ravi2, Ravi3, anything you want to name. Anything you want to name, just give the name to it, and then we use these keys. Okay, go to the GGSCI. Okay, view param CT1, encrypt password. Password is Oracle. Okay, so what I said, encrypt password Oracle, encrypt key K1. So I'm using key K1. I'm using K1 key to encrypt the password. Oracle is the password, you know that. So what I'll do, I say edit params ct1, right? That's the name of the file. I paste it here. Oh, it's not copied, I think. Okay, view param ct1. So in this way we are going to encrypt it. So the use extract ct1, user id this, password this, encrypt kit k1. Stop the extract. Maybe we might need to add blowfish as well. Blowfish is the algorithm we are using. Let me see. Starting. Okay, so this is the way we did it. We first generate the 4 keys, okay, and using keygen utility, put it in the file known as enc key. So enc key is in standard name. It's not like it is a fixed name. You cannot have any name if you want. You need to make a file enc keys, because whenever we are reading it, when we are doing it, GoldenGate will read this file with the name of enc keys, because you see that we are not giving any reference to the file name over here. We are just giving a reference of key name, right? Encrypt key k1 everywhere, because by default it would be reading from that enc keys files only. Okay, so you need to copy the same file. You cannot create a different file on the target, because the target and source will communicate during message encryption. But if message you are not doing a messages encryption, you are just doing the password encryption, then it is fine. No need to copy. You can have different enc keys files over there, right? It's understandable, right? Because anyways they are not communicating on encryption, but we are doing a messages encryption, then we have to do it. Okay, okay, it is running. So next comes the trail file encryption. Now you can see over here. Okay, so next comes the trail file encryption. So this way we did the okay, so we'll do the message encryption as well. Okay, okay, so next comes your trail file encryption. So in case of trail file encryption, you just need to specify over here encrypt trail. Okay, you have to specify over here encrypt trail. Okay, I say edit params ct1, because now this just before this exe trail parameter, I will say encrypt trail, encrypt trail, encrypt trail es 128, because you are using 128 bit length, and key name might be k2. It is key name. Yeah, so key name might be k2, k3, k4, anything you want to do. So your trail file is now encrypted. So let us stop and extract once more and start extract CT1. So now all the data now that is written now, okay, so the previous what was written, but now the next data which would be written would be encrypted. So you cannot read it from the lockdown utility. Okay, so your lockdown will not work, okay, for an encrypted trail. Okay. Now comes your trail file. Anyways, your canonical format as well. Might be there would be some tools to other tools as well available, right? So if it is not encrypted, there's always a risk. If somebody copies these trail files and take it to the machine, and maybe there would be tools available to convert this canonical format. So you have a risk to lose your data. Okay, to so that other can view the data. So in this way you can encrypt. But now pump has to read this file. Now, when pump will read this file, it has to decrypt the file, right? It has to decrypt the file. So there were similarly for pump also, when the pump is reading it, because it cannot also read this encrypted file. So what it has to do? It has to decrypt the file. Okay, it has to decrypt the file before sending it to the target. Okay, before remote host, you need to specify this parameter decrypt. So decrypt trail AES 128 same. And what was the key name? Key name was K2. You need to stop the extract, stop extract PP1, and then start extract PP1. Start extract PP1. Okay. So now the next question you might be put in the mind is for everybody that uh, that this is decrypted, okay, but on the target it is again it is decrypted because for reading it need to decrypt it. Okay, so what about if I want that target trail should also be encrypted? I can put this again, encrypt trail. Okay, so before sending, before RMT host, I specify decrypt because before sending it, I have to decrypt it. Okay, before sending, I have to decrypt because to reading it for reading it. So okay, so before sending, I decrypted it, and now again before writing, I again encrypt. So it would be encrypt trail 128. Maybe this time I might be putting other key name. Okay, that is my wish. Maybe another key name K3 or K4 because I have 4 keys. Okay, so you can see this parameter file. Okay, so first I am decrypting the trail, decrypt trail, then I'm encrypting the trail again. So I'm just starting and stopping it again. Stop extract pp1, start extract pp1. Okay, so now it is written into a encrypted format in the target. That is your in the target. So in the target, replicate has to decrypt it before reading, right? So because replicate will also not be able to read the encrypted data. So if I go to replicate REPZ, that is my replicate, right? So what I will do before mapping, I will encrypt it. Okay, before mapping, I will say decrypt. Same AES 128. And what was the key name we are using? We are using key name to encrypt the target trail file key 4. Okay, and we will stop and start our replicate. Okay, this is running as well. Okay, this is running as well. So they've come now. Whatever I send the data, now it is completely encrypted in the trail file in the source and target on both the servers. So you have to remember before reading, you have to decrypt it. So the pump configuration, just see, have a look at the pump configuration again. I decrypted and then I encrypted once more. Okay. Now about the messages encryption. Now who is sending the messages? Pump is sending the messages, right? So pump is sending the data. Pump is decrypting the data and sending it. So if somebody would be able to hack it from the network side, from the network, there is a risk, right? So for encrypting the data on the pump, because this parameter is actually sending the data. This remote host manager port, this is actually sending the data, right? Okay, so go to this file, okay, remote file, and we again going to specify your key name. Okay, so it's a key name, maybe k3, anything you want, k3. So specify key3. So anything which is sending to the okay. So I think we need to add blowfish as well, because blowfish, yeah, encrypt blowfish. Maybe I don't think. Let us see once. Okay. So what I added over here, I added the encryption technology, that is Blowfish, and keyname K3. So now it will encrypt your messages using keyname K3. Okay. So just the changes I need to make it in the target side is I need to tell the target of which how to decrypt your data. So which is actually reading our data in the target. So the data is read by your collector process. Okay, internally it is read by collector process, but what we actually do is we don't GoldenGate doesn't reveal it is read because there is no parameter file of collector process. All the things which is there in the pump parameter file. So pump is some communicating it, but now as encryption has happened, so now we have to configure our collector process. So as there is no what do you say, no parameter file, so what we have to do, we have to start in the GoldenGate home directory. We have to start in the GoldenGate home directory the collector process, which is known as the server. Why it is known as a server? Because it is accepting the request. Okay, server function. What is the server function and client function? Client is to send the request, server is accepting the request. So this is the collector is a server process, right? Accepting the request. So I have to start my server process explicitly. Remember, always on the GoldenGate home directory. Maybe on the no hop mode, because if you start over here, then you might that need to be open all the time 24/7, so your terminal, but better to on the no op mode so that it keeps on running. So you say /server and you specify the key name. Okay, so I say server -p port number, any port number you want to give. Okay, maybe this -p port number, and encrypt blowfish key name k3. Okay, so now this is listening this request. So now all the data which is coming to this point will be should be encrypted with K3. Okay, it either should not be encrypted at all, it should be normal data, no encryption, or only with K3. Okay, so you cannot have multiple encryption while sending the data. It should only send with this K3 process, because collector would be receiving all the requests. Okay, so either are not encrypted data, normal data, or it should be encrypted with K3. Okay, so this is all about encryption for the GoldenGate.